Okay, so we just found the probability of the first circle. So we knew that there were 5 in all and that there are 3 circles. So the first circle is going to be a probability of 3 over 5. Now, they said that she kept the circle that she first took. So that means that we are down to 4 in all and we're down to 2 circles. So our bottom number, our outcomes, are going to be there's only 4. And since there's only 2 circles left, we're going to put 2 over 4. Now, to figure out the probability of each, we need to multiply 3/5 times 2/4. Okay, so we're going to take 3/5 times 2/4 to get 6 over 20, which reduces down to 3/10, which is the probability of getting a circle both times. Okay, so since we have all of them in this one, all the circles, but then on this one, she kept it. So now we're down all the shapes and we're also down a circle. And then you multiply them, and then this would be the probability of getting a circle 2 times. Okay, so let's go ahead and look at on B. So B says, find the probability of a square, keeping it, and then drawing a circle. So we first need to find the probability of actually drawing a square. Okay, so now all the shapes are back in there now. This is a different one. So we know that we have 5 shapes in all. Okay, and it says that we have 2 squares. So we have to put 2 over 5 to get a square. Okay, so this is all of them. This is a probability for the first one. The second one, they want to know probability of getting a circle if she keeps the square from the first one. So that means we're down a shape, but we have the same amount of circles because she picked a square the first time. So we're down a shape, which is 4, but we still have 3 circles left. Okay, so we need to find the probability of getting a square the first time and a circle the next time. So since we need to find both, we need to do 2/5 times 3/4, which we're going to get 6 over 20, which reduces down to 3/10. Okay, so remember, this is a dependent event because she didn't put that square back in. So that means that we're down a shape, which means we need to go down in our denominator. Okay, now if we're talking about odds. So odds are another way of describing the likelihood of an event. So when we're talking about odds, we can either have odds of an event or odds against an event. So odds of an event is a ratio expressing the likelihood of an event, and this can either be for it or against it. Okay, so we'll go over example 4 where it talks about that a little bit more. So example 4 says, a bag contains 6 red marbles and 2 yellow marbles and 1 blue one. Okay, and then it says, what are the odds of drawing a red marble? Okay, so what are the odds of drawing a red one? So we need to look at the favorable outcomes and the unfavorable. So we see that there are 6 red ones, and then there are 3 marbles that are not red. So our favorable outcome is going to be picking a red one, right? Because there are more red than there are anything else. So we're going to have 6 marbles would be favorable. Unfavorable would be the 3 other marbles that are not red. Okay, because we have a better chance of drawing a red one than we do of not drawing a red one. Okay, so to put that in, a ratio, remember our ratio asks for, if I say I want favorable to unfavorable, I need to put my favorable one first. So the odds of getting one are 6 to 3, because 6 red marbles to the 3 not red, but we can reduce that even more because 3 goes into 6, so it's going to be 2 to 1. Okay, so favorable to unfavorable, since there are so many more red ones, that's going to be our favorable one. The unfavorable one is 3 because there are 3 marbles that are not red, so the odds of getting a not red one are a lot less. All right, now we're going to look at B.